So if you have an equation, something like this, there's only one variable there. We have x. You can give an exact solution. There's only one answer for this. You add 4, then you divide by 2. We know that x has to be 7 there. So when you have an x to the first equation, you can get a definite answer. All we have there is one variable. But if I throw something like this up there, x plus y equals 10, there is not a definite solution. Like, you could have 8 plus 2. X could be 8, y could be 2. You could have 4 plus 6. You could have 3 plus 7. If you have two variables in one equation, you cannot get a definite answer. There is not one solution. And that's actually why, if you graph this, it looks something like that. Every point on that line is a pair of x's and y's. That would add up to 10. That's what the graph of a line means. Every point on that line would satisfy that original equation. But for forgetting about graphing and all that, we're just talking about equations without doing any graphing. Let's say we have this. Again, I have two variables there. I can't give you a definite answer. There isn't one unique solution. There's a whole range of them. But what if I tell you y is equal to 2 times x? Well, then we could say, hey, y is, that's what equals means. Y is 2x. So I can put that 2x in for y into the original equation. I can substitute it. Divide by 3. And then we said y is twice x. So 2 times 3, y would be 6. What this means then, if you have two variables, you can't get a solution with just one equation. You have to have a second equation to get a definite solution. This is called a system of equations. If you have one variable in one equation, you can get an answer. If you have two variables though, you need 2 equations. And if you have 3 variables, you need 3. If you had 4, you need 4. This in algebra, you're supposed to stick to just 2 variables and 2 equations. Then in trig, you learn about 3 variables and 3 equations. Then if you take pre-calc, you'll do more than 3. Now, there's 2 main methods. The first one, like I just did on that last question I made up, it's called substitution. When you replace a variable with another variable, and maybe some numbers in there too. Just like when I'm not here and there's a substitute here, you don't see me anymore. You put it in place. Now, the way this works is it's substitution when you have a variable solved for. Now, what I mean by solved for is it says like x equals. Number 2, the bottom equation says y equals. If there are other letters, you might see G equals or H equals, meaning it's alone on its side of the equal sign. What this means is the equal sign means X and Y minus 1 in this question. Those are the same things. They're equal. So what you do, the solved equation, you put parentheses around the other side, and you substitute that expression, in this case, y minus 1, in for the x in the other equation. Again, I'm recopying this bottom equation right here. It's just instead of x, I wrote y minus 1. I substituted y minus 1 in. This helps me because now I have just a single equation with only y in it, so I can get a definite answer. Now I got to do some algebra, distribute the negative 5, so negative 5y, double negative, plus 5, plus 8y, equals 17. Negative 5y plus 8y, that's not negative, it's just 3y. Then we'll minus 5, divide by 3, y is 4. Well, we're done the hard part. With these systems, you need both an answer for x and y, or whatever two variables the question has. So what you do then, you go back to one of the original equations, and if there is an easier one, use the easier one. In this case, there definitely is an easier one. If I want to solve for x, look at this. In the top equation, x equals y minus 1. But hey, I just said y is 4. 4 minus 1, x is 3. Number 2. Now again, the way you recognize a substitution is that one of the variables will be solved for. Well, and I said substitution, I guess, it's highlighted still, but you know what I mean. Y equals, there it is. That one's solved for y. So again, slap parentheses around the other side. This one's equal to y, so I'm going to put it in for y. I'm going to substitute in for y. Negative x minus, now I'm not going to write y. I'm going to write what it says y is equal to. This time we got to distribute a negative. Negative x plus 5x is 4x. Subtract 17. Divide by 4. X is negative 3. All right, now we need to find y. Again, go back to one of these originals. If I want to solve for y, the bottom equation says y equals, hey, that's easy. X is negative 3. I'll plug that in. Negative 5 times negative 3 is positive 15. So y is negative 2. Number 3. Well, this time, the top one says y equals. So we'll slap our parentheses around the negative 3x minus 8. That is equal to y. So I'm going to substitute that in for y. Distribute the 4. negative 19x when you put those together. And I'm running out of room, so I'm gonna skip a step here. I'm gonna also add that 32 over. Divide by negative 19. Sorry, I kind of ran out of room, so I squished those two steps together. So again, there I combined negative 7 and negative 12x, and I added that 32. And then again, we got one variable, we need the other. Negative 3 times negative 1 is 3. 3 minus 8, negative 5. Number 4. Oh, this time it's back to x being alone. It says x equals 3y minus 11. Substitute that in for x. And actually on this one, you could have used either one, I guess. Doesn't really matter though. Though, we'll distribute 11 plus 77 is 88. Now we got to get our y's on one side, so I'm going to add that 21y. 1y plus 21y is 22y. This one was a little weird, but still works. What I mean by that, if you look, they're both solved. That doesn't really happen very often, but either way, we could have put the bottom, the negative 7x plus 11, we could have put that in for the top y, or we could do it the way we want to do it. And then that's one of the things about these substitution or the elimination questions we're about to do. There isn't only one way to do it, which can make it kind of confusing, because if you ask someone for help, maybe they did it a different way than you started to, but should be the same answer. Now, still got to go back and find the other one. 3y minus 11. 12 minus 11 is 1. So that was substitution. And again, the way substitution works, you'll see one of them will say like x equals or q equals or f equals or something like that. And yeah, sorry, it's been a while since I've used this worksheet, so I forgot about that. Number 4 was a little weird there, but they don't usually look like number 4, where you could do either equation, but anyway, now the other method is elimination. Now you can see this looks different. None of the variables are solved for, meaning like it doesn't say x equals or y equals. All the x's are lined up vertically. All the y's are lined up. This is a completely different method here. And this is the one that is slightly more important. You'll use both in trig, but this one is used much more and much more in pre-calc. But anyway, the way this works. You want to eliminate one of the variables. Like I had said, you can't have two equations, or excuse me, you can't get an answer to an equation if it has two variables. So we got two equations here that each have two variables. Just like with substitution, after you substituted, you only have one variable, but this is different. Instead of taking part of an equation and putting it into the other, we're going to add these two equations. Number 5, the first example of this is an example of an easy one. If I add these, look at the y's. You have a -2 and a +2. Those will cancel each other out. They will eliminate, which is kind of the point of this. -2 plus +2 cancels. Don't totally destroy your work though, because you're going to need those equations again. But I can just go ahead and add now. -5 plus 4, -1. -30 plus 26 is -4. Hey, there we go. That one's easy. The y's already had a +2 and a -2. They already had opposite numbers. So they would cancel right out and you're good to go. Now all I got to do, divide by -1, x is 4. And I had said, don't destroy the original problem there when you eliminate, because we need it now to find the other letter, find the other variable. Try to pick the easier equation, if there is one. None of the numbers are much easier than the other ones, but this bottom equation here, it doesn't have any negatives. I might as well just use that. So I'm going to put the 4 in, 4x. And like I said a minute or two ago, you could do the top. Absolutely no problem. You want to put that -5 times 4 in? No problem. Put it in the top. But the bottom doesn't have any negatives. Slightly easier. Might as well use it. Subtract 16. Divide. Y is 5. So the easy elimination questions, like that one, you'll have like a -2y, +2y, they'll cancel. You might have a 7x and a -7x below it. They would cancel. You just add them together, it eliminates that variable. And then usually you get an easy one-step equation. Now 6 is a little bit harder. If you look, you got a +5x and a +1x. 5 plus 1 is 6. That doesn't cancel. The y's, you got a -4 and a +2. You add those together, that doesn't cancel. You have to do some multiplication here to get one of the variables to cancel out. Try to pick an easier one. Let's say you want to cancel the x's out. Wouldn't be that bad. If I multiply the bottom by -5, wouldn't be that bad. I get a -5x, then the x's would cancel. But look, if I just look at the y's, I already have opposites. The top is negative, the bottom is positive. And it's real easy to turn 2y into 4y. All I got to do is multiply the bottom by 2. We got to multiply everything in the bottom by 2. I'm going to recopy the top. I'm going to multiply everything in the bottom by 2. Like I've said before, there's no one correct way to do these questions. If you had multiplied the bottom by -5, then the x's would cancel and you'd still get the same answer. Your work would be different. My advice is just find the easiest way. It was easier to multiply the bottom by 2 than it would have been to multiply by a -5. I mean, not much easier, but if I can make it a little bit easier, might as well. So 5 plus 2 is 7. The y's cancel. -9 plus 2 is -7. Divide -1. Now we'll go back to one of the originals. Neither one is that tough, but hey, look, the bottom has smaller numbers and the x doesn't even have a coefficient, a number in front of it. So if I just take my -1 and I plug it in for that x, hey, easy equation, add 1, divide, y is 1. So again, when nothing will cancel from the beginning, like on 5, we had a -2 and a +2. Those just cancel out. But on 6, nothing cancels out. But it wasn't too bad because I could just multiply the whole bottom equation by 2, and then I'd have a +4y on the bottom and a -4y on the top, and those would cancel. So keep that in mind. Now on 7, same idea. You know, 4 and -1, those won't cancel. 16 and 8 won't cancel. So you got to pick an equation to cancel out here. It's a toss-up this time. If I want to cancel the x's out, I got to turn the bottom into -4x. Well, it's already negative, so all I'd have to do is multiply by 4. Hey, that wouldn't be too bad. If I wanted to cancel the y's out, think about it. To get them the same, if I just multiply the bottom by 2, I'd have a 16. I'd have to use -2 though, so they're opposites. Multiplying by -2 wouldn't be that bad either. There really isn't much of a better choice on this one. I would probably just multiply by 4, so I don't have to worry about double negatives. But why not just to do one with double negatives to remind you here. I'm going to multiply the bottom by -2. Now, how does that help me? I'm going to recopy the top. On the bottom, and this is why I said I would have just multiplied by 4 if I was doing this. Because I got to worry about double negatives. -2 times -x, +2x. I mean, it's not very difficult, but, and then -2 times 8, -16y. Hey, just like I wanted, now those y's will cancel. Don't forget to multiply the other side. 24 times 2, 48, double negative makes it positive. There we go. I went probably, which would be the way I wouldn't do it, just to demonstrate here. You can do it either way. Now my 16y's cancel. 6x equals 48. 0 plus 48 is 48 divided by 6. X is 8. Neither of these original equations are really easier than the other. I'll just pick the top. X is 8. Four times 8 is 32. Subtract 32, 0 minus 32, divide. Now, those last two were probably a medium difficulty. We had to multiply one of the equations. Number 8 would be one of the tougher ones, probably. Nothing cancels out. If I'm multiplying, I can't multiply 3 by a whole number and get 5. I can't multiply 2 by a whole number and get 7. So we're going to have to multiply both of them. Now going into this, if you just think, hey, if I want to get the same number out of 3 and 5, I could turn them both easily into 15. Multiply the top by 3, the bottom by 5. Not too bad. 2 and 7, I could turn those both into 14s. Multiply the top by 2, or excuse me, multiply the top by 7. Multiply the bottom by 2. But those are both negatives. The y's are both negatives. The x's, you already have one negative and one positive. And the numbers aren't any tougher. So I'm going to do the x's here. Again, I'm multiplying the top by 3 and the bottom by 5. That way, I'll have a negative 15x. Don't forget to multiply everything. And on the bottom, we'll have a positive 15x. Don't forget to multiply everything. I needed to do that because now those 15s will cancel. And if you had done the y's, you would end up with, you'd have to multiply the top by 7 and the bottom by 2. One of them be negative, and you'd have to distribute a negative. You'd get a positive 14 and a negative 14. There isn't just one way to do these. Heck, I could have turned those both into 30s. I could have multiplied the top by 6 and gotten a negative 30y. Could have multiplied the bottom by 10 and gotten positive 30x. So we'll continue with this. Divide 0 by 41, you get 0. Go back to pick one of the originals. I'll pick the bottom, has a few less negatives. You could do the top, doesn't matter. If I pick the bottom, 3x, 7 times 0, 0. Divide